everybody, and welcome to this video on calculus. In this video, we'll be having a look at an example from a past paper. So we're going to have a look at a question from the 2014 Gauteng Department of Education exemplar paper. So the first question says, determine f dash of x, the derivative from first principles. Okay, so we've covered this type of question. So let us start at number one. The first step is for us to get f of x plus h. To get f of x plus h, in every place that we see x in the original equation, we replace it with x plus h. Okay, I'm going to simplify this at this stage. So we have that this here is x squared plus 2xh plus h squared, and just make sure you agree with that when we square that out, we get these three terms. If you're unsure, just do the step separately and make sure that you agree that that is what you get. And then we're going to distribute the 3. So we have 3x squared plus 6xh plus 3h squared minus 2. Okay. The next step is to then put in our formula for the derivative. So our derivative from first principles is the limit as h tends to 0 of f of x plus h minus f of x all over h. This is equal to the limit as h tends to 0. In the place of f of x plus h, I'm going to write this expression that we got. So we have that it is 3x squared plus 6xh plus 3h squared minus 2 minus, and then f of x was 3x squared minus 2. Please note that f of x I put in brackets so that I remember to distribute that minus to both terms inside the brackets, and all of this is over h. Okay, let's continue simplifying. So this here is equal to the limit as h tends to 0 of 3x squared plus 6xh plus 3h squared minus 2 minus the x squared plus 2 all over h. Now what we have is that the 3x squared cancels out with the minus 3x squared, and the minus 2 cancels out with positive 2. So what we are then left with is the limit as h tends to 0 of 6xh plus 3h squared all over h. So we can't let h tend to 0 at the moment, because then there'll be a 0 at the denominator. So what we'll have to do is factorize an h out of the numerator. So taking out an h, we get 6x plus 3h all over h. Then those cancel out, and then finally we can let the h tend to 0. So then we have 6x plus 3 times 0, which is then the derivative f dash of x is then just simply 6x. And then we are done. You can check that this is your answer by using the formula. Okay, so using the formula, you can just check that that does make sense. Okay. So let us have a look at the next one. So it says determine dy by dx if y is equal to 2x to the power of minus 4. So this is like that. Y is equal to 2x to the power of minus 4 minus x over 5. Okay. So we're going to get what's dy by dx. So we're going to apply the rules to each term. So the derivative for this one here is multiplying the exponent by the coefficient, and we subtract 1. And then we're going to do the same thing. We're going to multiply the exponent, which is in this case 1, times the coefficient, which is minus a fifth in this case. We're going to minus 1 from the exponent. So this here becomes minus 8x to the power of minus 5, and this becomes minus a fifth x to the power of 0. If you would like, you can write this as x to the power over minus 8 to the x to the power of 5, minus a fifth, because anything to the power of 0 is 1. And there is our answer. Please make sure that you have understood and been able to do this question. If you have not, if you struggled with the first principles, please go and review our video on calculating the derivative by first principles. And if you had a problem with using the rule, then please go ahead and look at those videos and make sure you understand it. Thank you so much for watching. Please subscribe and like, and continue watching the rest of the series. Bye.